A recent survey asked high school girls to name the sport they like to watch the most. The results are shown in the circle graph. Find each indicated measure. So we've got basketball, gymnastics, football, tennis, baseball, track, and skating. I don't even see soccer in there, which I find surprising. I'm going to go ahead and have to assume that these are British high school girls, and that when they say football, they mean what we call soccer, and that none of them said American football. This feels like a good guess. Anyway, a recent survey asked high school girls to name the sport they like to watch the most. The results are shown in the circle graph. Find each indicated measure. F, G. So from F to G, that's this arc right here. This is the baseball arc, which we can see is just 32 degrees. EGB, that's from E, and then through G up here, all the way until you get to B. Notice contains track, baseball, tennis, and footy, as they call it in the UK. And so track is 40 degrees, plus baseball, which is 32 degrees, plus tennis, which is 28 degrees. Do they play baseball in the UK? Plus footy, which is 108 degrees. Did I get them all? Track, baseball, tennis, footy. And you're going to go 40 plus 32 plus 28 plus 108, and you're going to get 208 degrees. From D to B, I'm going to change up the colors for you. From D to B, that's D to B, that covers basketball and gymnastics. Basketball and gymnastics, which is 51 plus 54 degrees, by the way. Don't forget our units here. 51 plus 54 is 105 degrees. And in a most excellent tennis pun, ACE doesn't contain, it doesn't even contain tennis. That's a tragedy. From A to C to E, that contains football for 108, gymnastics for 54, basketball for 51, and skating for 47. Can I assume that's ice skating? I don't know. They're just not very specific. So I guess skating might just be ice skating, or perhaps it is. It can also contains skateboarding, rollerblading, roller derby. I don't understand how roller derby works. I actually don't understand how skateboarding is scored either, or ice skating for that matter. Maybe that's why I don't like watching it. Anyway, there's your arc additions. Yay. Identifying congruent arcs. Tell whether these arcs are congruent. Well, notice that these radii here are going to be congruent, so at least we know that these are congruent circles. And in case you weren't sure, it has a diameter of 8, and so of course it has a radius of 4. So that means that they're congruent if their angle measures, their central angle measures are congruent, and they are. So yes, they are congruent because they have congruent radii, and they have the same central angle measure. NM and OP. NM and OP. I'm going to say no, they are not congruent, because even though they have the same angle measure, they are not congruent because they do not have the same radius. Since the small circle inside and the large circle inside are concurrent circles. So no. AC and BD. So from A to C and from B to D. Now that's within the same circle, so I would say yes. I would say that they are, because they are obviously the same radius because it's the same circle. And I am put 2 dashes to make sure it's not going to go to the first one. And they have the same central angle. Prove the similar circles theorem. So given that circle C with center C and radius R, circle D with center D and radius S, prove that C is similar to D. So in order to do this, We're actually not going to do this with a 2-column proof. We're just going to do this with some steps, and we're going to put the justifications in kind of a paragraph form. So follow along with me. The first thing that I would do to do this is I would take a circle that is a ski-wampus circle. I'm going to go ahead and fix that. I would take circle C and I would translate it so that its center was at D. So if you'd imagine taking this circle, and actually let's go ahead and put its center down to there. So step one, and we're going to write this down like this. Step one, translate circle C to circle D, moving the center C to point D. Nothing wrong with that. Now, we've got these two line segments that make the radii of circle C right here, which I've just done in red, and circle D right here, which I've just done in purple. And what we're going to say is that now what we want to do is we want to, for step 2, dilate circle C by a scale factor of, and can you see what we want to dilate circle C by a scale factor of? We need it so that something times R is equal to S. So the scale factor would be S over R. Why? Because that would change the radius of circle C, S over R times R. Those divide out to S. Now, there are matching radii. That is, what we've just done is we just dilated the small circle by a scale factor so that it becomes just as big as the big circle. That is, they have the same radius. So, our new circle is congruent to the original circle D by, let's see, look up here. That was the congruent circles theorem. Two circles are congruent circles if and only if they have the same radius. That means since they have the same radius, by the circles radius congruence theorem. So step 3 is that since there is a set of transformations, specifically a translation, and a dilation, that maps circle C to circle D, they are similar by definition. And since circle C and circle D can have any radius, all circles are similar. Yeah, because if circle C had a radius of 4 and circle S had a radius of 8, the scale factor would be 8 divided by 4, which is 2. If circle C had a radius of 17 and circle D had a radius of 23, then we would have dilated by a scale factor of 23/17. Okay, and there you have it, folks. There's finding arc measures and some things about circles. I hope you learned a bunch. If you have any questions, send a message to your instructor. This is Mr. P signing off, and I hope you have a wonderful rest of your day.